going to be talking about revolutionizing media workflows through what we refer to as intelligent content discovery. So we'll walk you through this, and we have some demonstrations and other exciting things. But first, little housekeeping here. We have 3 speakers today. We have Bryan Rutkowski, who is a customer engineer in media for Google Cloud. We have Hodun, who's a machine learning specialist with Google Cloud. My name is Buzz Hayes. I'm the global lead of media and entertainment solutions for the Google Cloud Solutions Architecture team. Quickly, our agenda for today, we're going to start with an overview of what this notion of intelligent content is all about. We'll give you a walk through some of the steps to how that solution is put together. We'll talk about how this applies to archives and online or cold storage in the cloud. We'll also be talking quite a bit about the use of AI and ML tools for media. You'll have a demo of one of our partner tools that surfaces in a very elegant visual fashion, will surface machine learning data, metadata that makes it very easy to search your content. We'll also be doing a discussion about how Discovery, our pals at Discovery, thank you for being here, are using intelligent content in their monstrous archive, and awesome archive, I should say. And we'll also tell you how to get started on this whole process. For those of you who have the Next app, if you go to this particular session, you'll find a link for a Dory. So if you have any questions, feel free to enter it there. We also have microphones here, so feel free at the end. We'll have some time for Q&A to step up to the mic and ask the questions. So without further ado, let's take a look at what intelligent content is all about. So we're going to take sort of a top view here of the process. It starts with consolidating the media. You've got media in all sorts of places and in all sorts of forms. So you really want to bring that all into a single platform, or at least a similar platform. It may be cloud, but it may be multi-cloud in this case. But you want to put all your assets together. Then you want to apply machine learning tools, and we have a lot of automated tools now that are not only easy to use, but they're also easy to modify, which is great, and Drew will get into some of that in a little bit. But this allows you to gain new insights and apply metadata to both your audio and visual data. And that includes documents and photographs as well. And then once your content has intelligence, you basically have the power of your entire archive at your fingertips. A lot of archives right now don't exist in any meaningfully searchable form, and we'll get into why that is in a minute. But ultimately, you want to be able to find everything that's in there and leverage that for whatever purpose. So the vast majority of media archives, especially at the Hollywood studios and television entities, exist in a form that can't even be viewed, let alone monetized. So we have some solutions to help figure that out as well. And then once the library is made meaningfully searchable by adding the metadata, using the machine learning and AI tools, you can begin to broaden your use of these tools to gain further insights and derive analytics from that content, which can be very important. And so it increases the level of insight you have into this content pretty dramatically. So let's go a little bit deeper into this. Here's how it works. You're basically starting by ingesting the content into GCS, into cloud storage. And that storage the content can come from a variety of places, whether it's already on some spinning disk someplace on a server, some physical storage like tape, for example, a data tape. It could also be videotape, it could be film, other things, but they have to be digitized, obviously. So once all of those assets are available, you ingest those, import those into cloud storage, and then using a variety of the GCP tools, we can then apply all of the various relevant tools to derive these insights. So whether you're trying to derive visual information from images, you're trying to derive speech from audio, you're trying to derive text from images, a variety of things can be leveraged, and mostly automatically, which is great. And then you can start to visualize that data through various ways, and you'll have a demo again in a few minutes of one of the partner solutions we have for visualizing that data. How many of you use media asset management software at this point? Yeah. How many of you absolutely love the tool you have? Wait, I don't see any hands. Something's wrong. Okay, it was once asked to me by a studio client why media asset management can't be as simple as a Google search. And the beauty of the intelligent content discovery is that it can be as simple as a Google search. You want to be able to ask questions the way the humans who are looking for the answers are asking them. That scene with the woman in the blue dress and she said good morning, she had a hat, you know, that kind of thing. You want to be able to surface meaningful data from even obtuse queries like that. And then once you have that, you can activate this content in a variety of different ways. And I think there are many gold mines sitting out there that are yet to be explored just because they don't have meaningful metadata attached to them. So there are a number of different formats out there, and apologies to any of you who are diehard supporters of any of these formats, and I'm about to diss here a little bit. But it's difficult to find insights in your content if it's sitting on some physical media that hasn't been brought into a platform like cloud to be able to analyze it. So you're still talking about a lot of LTO tape or some form of data tape. And as many of you know, a tape in itself is not inherently archival. I guess it depends on your definition of archival. If you talk to LTO manufacturers, they'll probably tell you that the tape will last 35 years, which is true if you don't use it. And then if you start to use it, you start getting wear and tear. That shelf life ends up getting much, much smaller. So you really rely on the physical storage. And luckily, you know, we have great partners like Iron Mountain who do a very good job of climate control and things for physical asset media. But it really requires diligence to make sure that that data is still good. And you have to check it. Also, with LTO, you tend to have to migrate it to whatever the newest format is, because most of these LTO formats are not backward compatible more than maybe a version. So you end up with significant physical damage possibilities, bit rot, for example, if it hasn't been checked in a while. So there's a number of reasons why LTO is becoming a bit more problematic, especially given the volume of content that we have now. It's almost too much. Major studios will migrate their entire collections to new LTO formats every few years, and it's becoming prohibitively expensive to do that. The manual tagging of assets, you know, a lot of people have been applying metadata. The term's been around forever. And they've been using human resources to do that, which is great. It's a bit error prone, because if you have 50 humans, they're going to be interpreting things differently. They're not all going to give the same results on things. Plus, it's a little bit error prone. And you're basically having to watch things, transcribe things, and really, it requires a lot of paying attention. And there's so much content that it's almost impossible for human beings to do all this transcription. So that's another reason why using something like intelligent content discovery makes a lot of sense. You also find in this day and age, if you're working especially in feature films, you have day and date releases of films that have to go out in multiple formats to dozens of countries. I was talking with an executive at Disney, and one of the latest Marvel releases went out in over 100 versions on the same day. So there's a lot of content that has to be taken care of, and some of that content is it has to be filtered because there are certain regional requirements. You know, there are censorship boards in various parts of the country that have very strict rules. There's often inappropriate content for various audiences. There's other things that has to be trapped before it goes out there. So compliance is a big issue. And so using the ML tools to automatically derive those insights can be very helpful, especially when you have these massive volumes of content. And again, to find that, traditionally, the inappropriate content required a person having to sit there and find it. So what if you knew what your content knows? So the idea is, if you're consistently applying the same tools and the same metadata, you're surfacing the same metadata for your entire library, you're going to find consistency is actually of a great benefit. You'll see in this demo in a few minutes that you can now surface things that are like something you found. So if you found something you really like, by having consistent metadata, you can also surface other things just like that, which can be very, very useful when you're trying to leverage the assets in your media library. So it makes the entire library, the life of that library, considerably longer if you find that you can use these insights to leverage licensing. A lot of studios now are finding that they have great revenue in stock footage that's not used in the film, but they shot it for the film. It's not unusual for a film to have a very high shooting ratio these days because of digital technology. It used to be when we shot film, we'd shoot a 10-to-1 ratio. For every minute of screen time, there'd be 10 minutes of capture. Nowadays, it's not unusual to have 200 or 300 to 1. So there's a lot of content that never makes it into the movie, so why not monetize that? But you have to know where it is first. So obviously, we want to be able to reduce the time it takes to do this. You need to prepare the content for your distribution, so we can apply these tools again to find sensitive content, to derive closed captioning, for example, a number of things. We want to optimize the content and adhere to whatever compliance process there is. Every country has different restrictions on that. And again, we want to create rich and consistent metadata. That's the key. So as the value that comes with intelligent media content is to really understand how to make meaningfully searchable metadata. It's easy to surface metadata that's not very useful. We want to make sure that it is useful, and we provide labels as part of that to identify certain objects in the frame. And then we can then search our content very quickly and cost effectively. We can also provide intelligent search capabilities for media archives and enable consumers to find their content very quickly and easily, and that's important. Especially in this day and age with deadlines being what they are. You also reduce fines and risks, of which there are very real when it comes to inappropriate content. And you can find new ways to monetize this content through the information that's derived. So let's take a quick look here at the steps on our way to the solution. As you can see here, you identify the right partner to get the data out of your data or your physical library, and that in many cases, some of the tools that we have, you can do that yourself, or you can partner with one of our partner companies to do that. You ingest your archives into GCP. We have partners that specialize in that as well. We have partners that help you migrate your tape libraries, your data tape libraries. We have other partners that will help you take your physical assets like videotape and film and migrate those into the platform. And then you can generate the insights from our Google Cloud ML tools in a variety of ways, which we'll talk about in a little bit. And then once you've got that, you can organize it and make it all accessible, which is really quite simple, again, because of the consistency aspect to the metadata. And then you really get some meaningful insights into these tools. And that's the important thing about most archives, because we haven't had the luxury of that in a while. So here's some of the media partners that we have, and this is by no means an exhaustive list, but from connectivity to data migration to the ML and AI tools to the actual content management. And the list is growing every day, and all of these are vital components to the ecosystem of the intelligent content discovery process. So very quickly, by moving your media assets into the cloud, you'll have unprecedented control over that content. However, there's many different types of media archives, and most of them are not digital. According to the Academy of Motion Picture Arts and Sciences, half of the films made prior to 1950 no longer exist in any form. And that's just because of neglect and the fact that it wasn't really considered something that people needed to hold on to until it was too late. So we're trying to curb that. And videotape is even worse. And I think we're about to realize that in a few years when we start to go back to these older archives and realize we can't read the data anymore. This analog content is really important to us. So we've been working with media archives all over the world to help come up with solutions to get all of the content digitized and make it intelligently searchable so that then it could be brought to market if that's the intention, or preserved, which is another intention of a lot of older material, but at least be able to make this, this content more stable and searchable. And then by applying media search, we can do really cool things like just entering a line of dialogue or the name of an actor or an actress or even their character name or what they're wearing in a scene or the location where they are, and be able to surface very quickly the visual content that relates to those searches that are asked in human terms, not in Boolean search terms, for example. So if you're using the power of Google Cloud, you can definitely find what you and your audience is looking for by applying this data. So with this huge variety of both digital and physical assets, we need more and more efficient solutions to be able to migrate this to cloud. And that's sort of key in all of this, is getting stuff in there quickly. Here's some overviews of storage solutions, because we have a variety of different use cases here. And so we have streaming video, we have video transcoding, backup, archival, and disaster recovery, to mention just a few. And we have different storage classes for all of those, as you're probably all aware. We also yesterday announced a new cold line storage tier, which is arguably less expensive than tape, which is great. This is for data that's far less than what you would normally use for regional storage. So it's important to note that you have different levels of storage for all of the different media needs you have. it's important through all of this that when you're trying to derive the insights from this metadata, that it's put into a useful form where you can actually read it and make sense of it. And I think it's really important to know that there are tools out there that currently do this for you. I don't know if any of you have seen the output of just an ML process, but typically it's just a gigantic JSON file with a ton of text and numbers and brackets in it. And it's not the most friendly thing to work with. So to show a little bit more about how these insights can be leveraged, I want to introduce Drew Hodun, who's going to walk you through the machine learning and AI aspects of the intelligent content discovery. Drew?
Awesome. Thank you, Buzz. So let's talk a little bit more about the capabilities we can implement on our content once it's in the cloud, once we have it in a more usable, accessible format. So within Google Cloud, we provided a variety of different ways to use machine learning, from off-the-shelf APIs all the way to the latest and greatest in machine learning researcher and data science tools. We're going to focus mainly on the off-the-shelf APIs, the models that Google builds and maintains using Google-sized data sets and Google expertise. In particular for media, the media archives that we're talking about, our Vision API and our Video API are critical first steps to tagging your data. We'll talk about a lot of the different things that you can get out of these APIs. It's worth noting that you can call these APIs with a single RESTful call. You don't need to have a tremendous amount of compute in Google Cloud or a tremendous amount of ML expertise. It's very easy to add these into existing applications. So these APIs we'll talk about some of the methods, but detect a lot of predefined labels in the models that we build. But you'll notice up here we have AutoML Vision, AutoML Video, which we just announced. These are really powerful capabilities that allow you to define what you're looking for in your content. You need to provide some training data, and we'll show you a really easy way to do that. But then you can run these AutoML APIs on your data and get the tags and the information that you care about, not the tags that's part of just the Google taxonomy, right? That's something we hear a lot from customers is the off-the-shelf APIs that they see across Google and other providers are nice, but they have really specific things they're looking to detect. And they have on-the-ground expertise, producers, et cetera, who are looking for very specific things, but aren't ML experts, or maybe even developers. And so we'll show how we can integrate that. Here are a lot of different things you can do with the APIs. It's not just limited to vision or video, right? There's all the standard metadata tagging we get with our video and vision APIs. We're doing things like logo detection, landmark detection. We'll actually tell you latitude and longitude if we recognize a landmark. We'll recognize faces and sentiments. And this is sort of the backbone of your smart media archive, is just all the tags you get. What is in the frame on the screen? We can also use speech to text. So this is transcription. If there's audio, if you have an audio file or there's audio in your video, we'll output in a highly accurate manner what is being said. If there's multiple speakers, not an issue, we can handle that as well. We do translation. So this is part of that localization challenge, right? How do we create translated transcriptions of what's going on? How do we make our content searchable in multiple languages? Even if we're not doing closed captioning using this, it would be great to know what's being said in a video across many languages to then make it searchable and discoverable by our users. And if you have a relatively small data set of labeled data and you want to improve the API, you can do that using AutoML Translate. You'd provide us your labeled data, either a dictionary of word to word or sentence to sentence. And with a click of a button, we'll train an even more accurate translation API just for your usage because it's using your data to improve it. We can do sentiment extraction using the natural language API. So is this a generally positive clip or a generally negative clip, among other things? We can classify very quickly what is in the clip, like I said. One of the things that Video Intelligence API will also do is shot detection. So it helps you to break up your video and then discover what is in these different shots, so you can either quickly find and create content shot for shot, or in some cases I've worked with customers that actually generate content on the fly using techniques like the shot detection. So let's dive a little bit deeper into the Video Intelligence API and the AutoML Video API and talk about the methods we have. So with a single API, you can tell us to run one or all of these ML passes on your data. So there's the label detection, and that's what are we seeing? What are the actions that are happening? What's on screen? We'll do text detection, or OCR. So if there's any text on screen, you'll get that, and that's really valuable from a search standpoint. Logo detection, really important if you're looking for content to build a partnership or understand how often a partner is on screen. We'll do speech transcription. So even though you're sending in video, so it's audio and video, we'll do the transcription as part of that single API call, which makes that a lot easier for you to implement. Explicit content detection is critical, so understanding what is on screen when it might be more sensitive. In particular, for localization, different markets care about different aspects of explicit content detection, whether it's violence, adult content, et cetera. And we mentioned the shot change detection. All of this can be done with a single API call. Huge amount of information you get back on your content. So some new announcements with the Video Intelligence API in particular. We used to just offer batch mode, which was you had a video file on Google Cloud Storage, you would call the API and point the API at that file. We now support file streaming. So let's say you have a large file, you can create a gRPC streaming connection and send that basically byte for byte up to the API. You don't need to land that in GCS. Obviously, a lot of workflows, and the workflow we're talking about recommends that you have the content on GCS, but let's say you have either a real-time situation or a use case where the file's elsewhere and you don't want to move it, right? We support that now. And I mentioned real-time. We now support live streaming. So we support HLS, RTSP, and RTMP. Great for understanding live content, what's being said, what's on screen. Super helpful if you're doing custom ad placement, just-in-time ad placement. In the prefetch, for example, on online content, you can know in real time what's on screen and do quite a lot with that. So we're going to show you a demo using one of our several partners on the ML video intelligence end. So we're going to be using Zeroa Video Intelligence Platform, ZVI. So ZVI is as you'll see in a second, it's a really intuitive front-end GUI. It's the back-end document model, and also applies some custom ML and clustering ML as well. It's a really easy way to use all these APIs in an accessible manner, no coding required, and you'll see just how powerful the combination of these two technologies are. So behind the scenes, how the solution is going to work. First, you'd import the assets into Google Cloud, then index them. There's a clipifying process where we create proxies. So you might have a 2-hour file, but we'll create 3 5-second clips of that content. Just proxies, though, so we're not transcoding. We're not creating additional burden there. Then we can either use the Google ML APIs off the shelf or train our own models, and we'll actually show you both. We'll run all those ML passes over the content, and then you'll have the search capability across your entire archive. So here's the architecture you just saw. This is, again, in this case, we're using Zeroa as the front end, but we have a number of different partners. We've seen people build some similar solutions themselves. And this is the order: importing the assets, creating the proxies and indexing, training models, running the models, and then ultimately you get a very intelligent archive that you can then use to find content, to build that into your production workflow. There's quite a lot you can do with this. So actually, all right, so here we are in the Zeroa interface. We have gone ahead and, I need to refresh. So we have already run the clipification process, and all the ML passes across our data. So we have a data set. In this case, we didn't actually, maybe this is a data set that you don't really know what's in there. This is one of the powerful things we find out is you might have a ton of data and not even understand what's in your archive. We've seen this again, time and again with customers. So each clip we've run the ML passes on. So we can see here, if I select this clip, metadata on the left. We have all sorts of creative analysis. We have all the different tags we've pulled from the API. So we've actually detected some faces and pulled some values of the sentiment we see. Here are all the different tags that we pulled out of the API. And as Buzz mentioned, you get quite a lot of data out of these APIs. So one of the powerful things of a solution like this is we're not throwing away tags. We're just putting it in a database and making it searchable. So you're not having to look at this clip and look at all 50 tags. But when you search for it, it does get a hit, and it's there. And we've run, in this environment, we've run the video API, the vision API, speech to text. We've done natural language. We've done sentiment detection, and we'll show you AutoML. So we've run all these APIs already on this content. So now I can do things like Google-style search. I could search for house, right? And I get different clips of people's houses, inside, outside. Also, some clips of the White House. So if I search White House, that'll kind of zero in to a more specific search. If I do White House and portrait, you can see how quickly I found that specific clip I was looking for, right? This is very natural. This is how we search. And by the way, the search is going across the tags. It's going across the speech to text. It combines all this different data into a very intuitive interface. So for example, I can search, if I search mother, I remember that there was some, we shot a lot of, we had a lot of capture. There was a particular time where someone was talking about their mother that we wanted in this very long interview. If I run this clip, we'll actually find out.
And I'm a quilter, and I'm a mother.
So you kind of heard what was said. Within the metadata, we actually have a transcription of what was said in this clip. So now I can combine text searches with tag searches with some of the other capabilities that Zoro gives you. So one slick feature that you get as part of the Zoro front end is a clustering sort of image similarity or shot similarity search. So I can see here, maybe I have a shot that's like this, and I kind of like either the color or I like that scene. I want to find other shots that are similar. Oh, that's not a good one, sorry. We'll take this one. And with that image similarity search, I find all of the other clips that are similar from a clustering standpoint. There's some unstructured machine learning going on here. What's cool with this is the kind of, we'll talk about what we can do with that in just a second. We can see here, we've actually created some smart searches using these tags. So we have lots and lots of tags in the back end now. With this interface, it's really easy to decide tags we care about, build a smart search, and then do things like, hey, I want to find all the different angry clips where someone's angry. Maybe combine that with an actor's name. So I want all the angry clips of actor A, B, or C. And I can create these smart searches if I know what I'm looking for ahead of time. If I'm not, I just type into the search bar the way I've been showing. We do OCR, so if there's text on screen, that becomes searchable as well. Now the last thing I'll show you, which I think is very slick, is our AutoML integration. So you can upload your content into AutoML, train a model, do that all in the Google Cloud Console. We have several partners, including this, that will actually integrate with the API, so you don't even have to go into Google Cloud yourself to do this. So for example, we've built up a small training set. You can see I have 13 videos, 13, 12, 11, of different shot types. So this is something that the API was not returning. It wasn't saying this is a close-up, this is a medium close, this is a full or long shot, but this is a tag that I really care about as an end user, right? This is, from a production workflow standpoint, I really want to know what were the shot types, and maybe we have a different definition than someone else might. So with just a small amount of data here, you can see the different shot types that I've classified: close-up, full, medium shot, right? We have built an AutoML model, and it's pretty easy to do. You right-click and click Train with AutoML Video or Vision. Vision would take thumbnails, build a training set, and now you have a custom model. Video will look at the entire clip and build a model based on that. We can see here that just from these 13 videos in each category, when the model got trained, it was then applied to the entire archive. And we can see here, I've identified all the close-up shots in my archive using just 13 examples. I've identified all the full shots in my archive using just those few examples. And I can actually kind of tune the sensitivity if I want to make it even more certain that it's a full shot. Not only that, I can improve the model over time. So one of the things I can do is if I identify something that I don't think is a full shot, see if I can find one. Maybe I'd say this isn't a full, this is maybe medium. What I can do is take this clip, can add it to, all right. You can very easily add it into the folders into that training set, right? Live demos, right? And then you'd have the new data, hit train with Google AutoML Vision. Without going into Google Cloud Console, right, this data is going to be uploaded. You have a training set. 20 minutes later, that new model gets applied across all of your archive. So very easy to consume ML, even for your producers, whoever is interacting with this content. All right, so with that, I want to head off to Bryan Rutkowski to walk you through the next section.
So my name is Bryan Rutkowski. I'm a Google Cloud Customer Engineer, and I've been working with Discovery for a little while now. And it's really my privilege to be up here today because the work we've been doing with Discovery is really actually transforming their content into intelligent content. So this is real live production stuff here against thousands of hours of content. So I'm excited to talk to you about it today. But before I begin, could I see a show of hands of how many people have used our ML APIs before? A few of you, all right, great. Well, hopefully after this you'll all go out and try it. But for those of you that haven't used it before, like Buzz alluded to, whenever you run an ML API, this is what's returned, a lot of JSON. And you can imagine if you've got thousands upon thousands of hours of content, just imagine how much JSON you'll get back. What do you do with that JSON? How do you get value from it? How do you normalize it? How do you store it? Where do you store it, right? But probably more importantly, how do you actually visualize it? How do you, gain value from that machine learning? How do you make your processes more efficient? How do you make your workforce more efficient to save time? Right? So let's talk about how Discovery is doing this today. First, they have a partner named SDVI, one of our Google Cloud Technology partners. And SDVI has been in this business for some time now. They work with large media companies like Discovery, Fox, Sky, and Turner, as well as others. And what they do is they focus on the media supply chain. They are able to manage and optimize the technical applications in order to process content. They abstract that infrastructure that's needed to do all of this. And one example is they can actually automate the process of running all the content through our ML APIs. So the way that SDVI describes themselves as, they're like a factory, right? You're a large media company, you're getting content in from producers or other sources. You've got to do a dozen, multiple dozens of things to that content before it's ready for distribution. And SDVI really helps automate that entire workflow for you. The other key thing is, how do you actually, again, make this valuable to your workforce? How do you, really enhance their abilities to do their work? And SDVI has a program called Rally Access, which is a plugin for Adobe Premiere. So this is what Discovery actually utilizes to visualize all of that ML data in their editing suite. And what this allows them to do is things like compliance and distribution versioning, metadata tagging, caption validation, among many other things. So let's talk about what Discovery is doing today. Discovery is utilizing our Video Intelligence API to do labeling, explicit content detection, speech-to-text transcription, and all of those things are allowing them to allow their editors to search for labels right into Adobe Premiere. It allows them to find words that people said. You can search through that content and find where somebody said something in a piece of content. And in doing this, it's really making them more efficient. They can go in, edit a video, send it up to the cloud for rendering, and save a lot of time in that process. And what it's doing for Discovery is enhancing their QC process. It can take 1 hour, or for 1 content hour, it can take up to 2 hours normally to do a QC. This is helping them cut that down to sometimes 15 minutes. So that's a huge savings, right? But then layer upon that how many thousands upon thousands of hours of content come into somebody like Discovery every year. And you can immediately see the massive savings that machine learning can provide a company. So at a high level, this is what we've helped Discovery build through the help of SDVI and Discovery. You can see on the left, they are ingesting content from multiple data sources. It gets ingested into Google Cloud and stored on our object storage. And then they can run a transcode on that to create the proxy file, which is what's going to be used to run the ML APIs against. So you take that proxy file, run it against each of the APIs, and get all that JSON data back. And then you store it in the SDVI Rally database. And that's where they normalize the data and make sure it's in a format that's ready to be consumed by an end user. And then on the far right, you can see how somebody on-prem or anywhere could go into Adobe Premiere, see their task orders, their work orders, and actually start to edit that content in Adobe Premiere, pulling that ML metadata out of the cloud. So I'm going to show you a video of how this looks in SDVI's Rally Access panel. So you select your task order. You can go in and then select the labels with the time-based metadata showing up. On the left, you'll see that there's actually time-based metadata for each label with the ins and outs for that particular label. So you see they can select one, and it shows right on the editing panel where that video is. So if you need to find, say, or search for some explicit content, for example, that would take you right to that point in video. So you're not spending time looking through that entire video trying to find specific things that need to be QC'd. So you can also see in the middle there, they have the time codes right in the sequence. So you can go in and see exactly, as you're scanning through that file, what the labels are during that sequence. So this is what Discovery is utilizing today with the help of SDVI and our machine learning technology. Now I want to talk to you a little bit, how can you get started doing this yourself? And there's really 3 ways. One is talk to your account team, somebody like me, a Google customer engineer, and we can help guide you through this, give you demos, get you in touch with partners on how to build this yourselves. You can talk to the partners themselves. They can show you what their technology can do and help you. And then you can engage with our professional services organization. And they're the ones that will actually come in and help build this with you, actually deploy it in your environments,